Okay, so this is May-June 2019, paper 23. Okay. All right, question number 1, part A says a sample contains 3 different types of atoms: argon 40, potassium 40, and calcium 40. State fully in terms of subatomic numbers of subatomic particles what these 3 atoms have in common. So what do they have in common? What's the same about these 3 atoms? They have the same nucleon number, right? So that in terms of subatomic particles, they have the same total number of protons and neutrons. And what's different about them? And neutrons, exactly. So they have different numbers of protons. बांट रहे हैं 2 मार्क यहाँ पर, दोनों हाथों को ले रहे हैं, electrons and neutrons. Okay, obviously इसके 18 प्रोटॉन है और 22 न्यूट्रॉन्स हैं. Electrons obviously protons जितने ही हैं, 19, 21 protons, neutrons 20, 20. All right. A sample of sulfur contains only 2 isotopes, sulfur 32 and sulfur 34. The relative atomic mass is 32.09. Calculate the percentage abundance of the isotopes present in the sample. How do we do this? Anyone remember?
100 minus x.
Yes. So since they're saying there's a sample only contains 2 isotopes, so their total percentage is 100%, right? So if you can define any one as x, so let's say इसके x% है, तो बाकी कितने होंगे दूसरे के 100 minus sulfur 34 के. So we know out of 100 atoms, x of them have a mass of 32 and 100 minus x have a mass of 34. So that's the total mass. So the average mass is just this divided by the total number, 34. Divided by 100 is equal to 32.09. So what we get is 32x plus 3400 minus 34x is equal to 3209. Multiply 100 on both sides. We get 191 is equal to 2x. So x is equal to 95.5%. Right? So the abundance of sulfur 32 is 95.5 and the abundance of sulfur 34 is just 4.5%. usually एक सवाल आता है जो relatively straightforward होता है paper. The electronic configuration of a sulfur atom is 1s2, 2s2, 2p6, 3s2, 3p4. Identify which orbital has the lowest energy in a sulfur atom. The lowest energy, 1s orbital, right? 1s orbital has the lowest energy. Sketch the shape of a p orbital. Just literally after that. During the process of ionization, a sulfur atom loses an electron. Identify the orbital from which this electron is removed. Which orbital would an electron be removed? What's the 3p, right? Highest energy orbital se pehle lose hoga, right? And it'll actually be 3p4, so it'll actually be the paired electron that's removed first. Agreed? So, because that one experiences the most repulsion. So, what we have is the orbital that's removed from is a 3p orbital. And the explanation, why is it removed? It's the highest energy orbital. Energy orbital. Okay. And the other way, like highest energy orbital that is occupied, or you can also say that the electrons in this orbital are the furthest away, so they experience the least amount of attraction. Okay, so that's why it's the easiest to remove. Complete the diagram to show the arrangement of electrons within the third shell of phosphorus atom. Phosphorus की क्या configuration होती है? Here are phosphorus आपका. Phosphorus is 3p1, 3p2, 3p3. So 3s2, 3p3, group 15 है ना? So it's p3. So we can say that 3s2, phosphorus is neon, sorry, neon, not argon. I'll write down the shorthand configuration, neon, and then 3s2, 3p. So we have 3s2 and then 3p. 3. Explain why the first ionization energy of sulfur is less than that of phosphorus. Exactly, it's a break in the trend, right? Ionization energy बढ़ती है across a period. In this case, there's a drop from phosphorus to sulfur because there is a pair of electrons, right, present in one of the 3p orbitals in sulfur, right? Right. So they experience mutual repulsion from each other. Okay. Hence, it's easier to remove. Which makes them easier to remove. I'll write that in parentheses. Phosphorus, they're all unpaired, so they're not easy to remove. Okay. It's like 12 marks, 20% paper, not bad. Iodine is an element in group 17 of the periodic table. At room temperature, iodine solid has a lattice structure. Describe the arrangement of iodine molecules within this lattice structure. In any lattice structure, this is O levels. In any solid, how are molecules or how are particles arranged? They're arranged in a regular arrangement. Literally, that's the answer. Okay. Okay, literally, I'm not even kidding. Okay. They're held. Huh? Abe, like regular as in like what's the word? Like a rigid shape, nah? Regular as yani ki like they form an orderly lattice structure, like bricks, right? Like any solid basically held together in a uniform, you can say uniform, that's a better word. Uniform arrangement. Okay, or you can say uniformly arranged in the solid structure. List all of the forces of attraction present in solid iodine and identify which of these are overcome when solid iodine is heated to produce iodine vapor. All of the forces of attraction present. What are all of the forces of attraction? So there's physical forces of attraction as well as chemical. The chemical force kaun si hoti? Iodine molecules. Covalent bonds, yes, good. And what's the physical force present? Induced dipoles. So covalent bonds, right? That's the chemical force. And you also have van der Waals forces. Due to induced dipoles. Those are between the molecules. So which force of attraction is overcome when you're evaporating iodine? Induced dipoles, right? Yes. So the forces of attraction overcome are the temporary induced dipoles. We'll just use the word van der Waals. But you don't have to. Due to induced dipoles. Okay. Iodine reacts with aluminum to form a white solid Al2I6. The diagram shows the arrangement of the outer electrons within a molecule. How many dative bonds are made when a molecule of Al2I6 is formed? It's similar to what we saw with AlCl3, right? So what we have is AlIII, and I'll draw it out again, right? One of the iodine atoms, this is what you have. You have these two dative bonds that are formed. Okay. I'll show the electrons also. So two dative bonds. That's the answer. Describe how coordinate bonds form within this molecule. How do they form? Donates a pair of electrons. Exactly. So you can say that iodine atoms donate a pair of electrons to form a bond with aluminum. In a reaction between hydrogen iodide and concentrated sulfuric acid, the products are hydrogen sulfide, sulfur, iodine, and water. Write an equation for this reaction. You may wish to use oxidation numbers to help you. So this is a balancing equation question. So first of all, you have to first write down the reactants, right? We have hydrogen iodide and concentrated sulfuric acid. So write this down. We have hydrogen iodide, HI, and concentrated sulfuric acid, H2SO4. And what are they forming? Yes, hydrogen sulfide, sulfur, iodine, and water. So we have H2S, sulfur. Acha, for sulfur, you guys can write S or S8. They accept both. So we'll just stick to S. It's easier to work with. Okay. Sulfur, iodine, and water. So now just move this a little bit to the left. So this is your equation. Now we have to balance this. Now we have to balance this. HI पे 2 लगाना है. हाँ, but don't do that. Don't do that. Use oxidation numbers to balance it. Use oxidation. Iodine goes from -1 to 0. सही है. सही है. Iodine का change is -1 to 0. Goes from +6 to -2. Okay, or to 0. So yeah. Now, how do we balance this? Okay, so one way to, and this is actually a difficult question, but one way to think about this is this. Okay, one way to think about it is that sulfur is getting reduced for sure, right? +6 से -2 भी जा रहा है और +6 से 0 भी जा रहा है. So can I say that sulfur is going down by -8 here, right? And over here it's going down by -6, right? So the total decrease for sulfur is what? -14. The total decrease of sulfur is -14. You can think of it that way. So we can say that 2 sulfur atoms are overall, they're decreasing by -14. So 2 sulfur atoms overall are decreasing by -14. Agreed? Oh, sorry. ये क्या लिख दिया? ये. एक सल्फर एटम -6 से कम हो रहा है, एक सल्फर एटम -8 से कम हो रहा है, तो 2 सल्फर एटम -14 से कम हो रहे हैं. तो फिर आयोडीन का कितने आयोडीन एटम चाहिए होंगे टू इंक्रीज बाय +1? 14 चाहिए होंगे ना. अगर सल्फर -14 से कम हो रहा है टोटल 2 सल्फर एटम, So that each iodine is going by +1. So we're going to need 14 of them to balance the changes. Agreed? Right? So we can say that we're going to have how many HIs? We're going to have 14 HIs for every 2 sulfurs. So we can say that we have 14 HI. Okay, which leaves us with 7 I2. And then the last thing we have to balance is oxygens, and we have 8 oxygens here. वो खुद ही हो जाएंगे ना यार भाई, ऑक्सीजन तो एक ही जगह है ना, 8 यहाँ पर हैं, तो फिर H2O कितने होंगे? 8, और हो गया बैलेंस. Okay. Okay. Explain with reference to oxidation numbers why this reaction is a redox reaction. So this reaction is a redox reaction because with reference to oxidation numbers, you mentioned the oxidation numbers, right? Iodine is oxidized from -1 to 0, and sulfur is reduced. Sulfur is reduced from what? +6 to 0 and -. Okay. So this is obviously the reducing agent, but it's oxidized, and sulfur is the oxidizing agent, but it's reduced. All right. Magnesium reacts with oxygen to produce magnesium oxide. State 2 observations that will be made when magnesium is heated strongly and placed in a gas jar of pure oxygen. White flame, right? Bright white flame. Magnesium keto. And what? What would happen to the metal? The silvery metal, what would it turn into? White powder, right? Solid, yeah, essentially a white powder, exactly. So, and white solid will be produced, right? Bright white flame observed. White solid is produced, okay. Acid indigestion is caused by an excess of hydrochloric acid in the stomach. Magnesium oxide is commonly found in indigestion tablets. Give the equation to show how magnesium oxide relieves acid indigestion. Magnesium oxide is reacting with hydrochloric acid, right? Caused by, you have excess hydrochloric acid, so you're using magnesium oxide to simply react with HCl to form MgCl2 plus H2O, right? And you're gonna have 2 HCl. They can get flushed out also, no? And matlab, so there's, let's see. Name the type of reaction that occurs in B part 1. What's this? What is it? Base plus acid, salt in water, yeah. Neutralization. Okay. Magnesium oxide is described as a ceramic material. State and explains why ceramic materials such as magnesium have high melting points. It's a giant ionic lattice, right? Ceramic materials can also, the ceramic materials are basically giant structures. So they can have, it's a giant ionic lattice or giant structure. The key point here is the fact that it's a giant lattice. In this particular case, it's ionic. Okay. Hence, a large amount of, or a very high amount of energy is needed to overcome these strong forces of attraction, right? Strong ionic forces of attraction or ionic bonds in this particular case. Okay, you can say electrostatic forces of attraction, same thing. All right. Magnesium oxide can be made from magnesium carbonate in a one-step reaction using heat. So what is this? Yeah, decom. So magnesium carbonate. Magnesium carbonate is decomposed into what? Yes. Oxygen कहाँ से आ गया? नहीं, वो नाइट्रेट से बनता है. नाइट्रेट से क्यों बनता है? So let me. This actually brings me to a different point as well. Nitrates to nitrogen dioxide and oxygen जो बनता है, it's a redox reaction. Oxygen is released in the process. Think about it. Nitrate में nitrogen is +5, nitrogen dioxide में nitrogen is +4, and oxygen goes from -2 to 0. Okay, this is not a redox reaction. Thermal decomposition of nitrates is a redox reaction. Thermal decomposition of carbonates is not a redox reaction. Oxygen isn't released in this process. Okay, so here we have magnesium oxide and carbon dioxide. Okay, and you have to give state symbols. So solid, solid, and gas. The type of reaction that occurs is just thermal decomposition. All right, next part. This is question number 3 then. Question 4. Okay. Release of sulfur dioxide into the atmosphere causes acid rain. Explain why high levels of SO2 may be found in the atmosphere near power stations that burn fossil fuels. The fossil fuels, huh? Impure fossil fuel, right? So usually fossil fuel, especially coal, has very high amounts of sulfur impurities in it. And those sulfur impurities are oxidized to form SO2. Okay. So we can say that sulfur impurities present in fossil fuels, right, are converted or are combust to form SO2. The SO2 released can be converted in the atmosphere into sulfuric acid by the following reaction with nitrogen dioxide gas and water. So SO2 and NO2 make NO and SO3. We know this reaction, right, to form sulfur trioxide. And then the sulfur trioxide reacts with water to form sulfuric acid. During 1 year, 1,500 tons of SO2 was released into the atmosphere by a fossil fuel burning power station. Use the equation to calculate how many tons of H2SO4 were formed. Assume all the SO2 released was converted into H2SO4. Exactly. For every 1 mole of SO2, you make 1 mole of SO3. And for every 1 mole of SO3, you make 1 mole of sulfuric acid. So the ratio of SO2 to H2SO4 is just 1:1. Right? So we can say your number of moles, 1590 tons after SO2. So our number of moles of SO2 is equal to 1590, the mass, times 10 to the power of, not 3, sorry, 6, right, in grams. 1,000 kilograms is a ton and 1,000 grams is a kilogram. So 10 to the power of 6 divided by, you can just keep the 10 to the power of 6 throughout because you have to give the answer in tons as well. And SO2 का mass क्या होता है 32.1 plus 64. So 1590 divided by 96 क्या होता है 96.1. How many moles? 16.545 into 10 to the power of 6 grams of SO2. Oh, sorry, grams क्या कह रहा हूँ? Moles of SO2. Right? So then we can say that the number of moles of H2SO4 is the same. Right? Number of moles of H2SO4 is equal to the mass over the molar mass. The mass is what we have to find. We have 16.545 times 10 to the power of 6 times the molar mass. Sulfuric acid ka molar mass is 2 plus 32.1 plus 60. Oh wait, I did something wrong here, didn't I? No one's even correcting me. ये 32 नहीं होगा SO2 के mass में. बताएं फिर से क्या आ रही वैल्यू 64.1 24.805 times 10 to the power of 6 moles. So we have the same number of moles of H2SO4. So 24.805 times 10 to the power of 6 multiplied by 98.1. This is equal to the mass. हाँ देखो मुझे पता नहीं आंसर देखो ना क्या आता है. What is this mass coming out? 2433. हाँ तो आगे आ क्या रहा है वैसे 2437. Okay. Times 10 to the power of 6. Right? So this is obviously just grams. So then grams, we just get rid of the tons. To get to tons, we just divide by 10 to the power of 6. So we have 2433 tons of 3 दे दो 4 दे दो, it doesn't matter. They're not as nitpicky in chemistry. बस कम नहीं होना चाहिए. 2400 नहीं बोलना, ज्यादा हो आप पूरा दे दो, ये भी दे दो, फर्क नहीं पड़ता, लेकिन कम नहीं होना चाहिए. क्वेश्चन में अगर स्पेसिफाई क्या हुआ 3 दो या 4 दो, then obviously you have to give it to the exact one they asked for. Yeah. Describe how NO2 is also produced in these power stations. Nitrogen, yes. The nitrogen, so how is it produced in these power stations? But why? Like, so you have to explain. Nitrogen isn't normally formed very easily. Nitrogen dioxide आसानी से नहीं बनता क्योंकि नाइट्रोजन के strong triple bond होता है. तो फिर क्यों बन रहा है power station में? Exactly. So what we have is we have high temperatures in the power stations, right? Provide the activation energy needed to break the N bond. Okay. And causing nitrogen and oxygen to react, and that forms the nitrogen dioxide. State one natural cause of nitrogen dioxide, light. बस यही है, लिख ले बस. Explain why NO2 can be described as a catalyst in the oxidation of atmospheric sulfur dioxide. Yes. So first of all, why can it be described as a catalyst? There's two things. What does a catalyst do first of all? So you have to first mention that it lowers the activation energy. Okay. Without itself being changed at the end of the reaction, being consumed at the end of the reaction. and you can obviously write down the equations if you guys remember. SO2 reacts with NO2 to form SO3 plus NO, and then NO reacts with oxygen to form NO2. Acha guys, just to be clear on this, nitrogen monoxide can also catalyze the formation of sulfur trioxide. In that particular case होता है पहले ये reaction होता है और फिर दूसरा reaction क्या होता है? नहीं नहीं ना, आप देखो मिसाल के तौर पर अगर आप ये लिखो, copy this, let me paste it here, right, and copy this. Just a point of clarification here. Because sometimes, I hate the selecting tool here. So यहाँ पर if you see, right, what's happening here is, okay, पहले nitrogen monoxide is being converted to nitrogen dioxide, and then the nitrogen dioxide is catalyzing the formation or reacting with SO2 to form SO3. So in this particular case, what's acting as the catalyst? NO. Over here, what's acting as the catalyst? NO2. So they can both oxides of nitrogen can act as catalyst. It's just the reverse order you write the equations in. Okay. Halogenoalkanes react with a number of different reagents in nucleophilic substitution reactions. A sample of potassium cyanide dissolved in ethanol is added to a sample of 1-bromobutane. Yes. Potassium cyanide is KCN and ethanol is added to bromobutane and heated under reflux. A nucleophilic substitution reaction occurs and compound A is formed. Name compound A. So what's happening here is CH3, we have CH2 thrice, and then the Br is replaced by a CN. So then what's the name of this compound? How many carbons is it? 1, 2, 3, 4, 5. So pentane nitride. Pentane nitride. What is meant by the term nucleophile? Yes, but you have to be more specific. What does the nucleophile do in any reaction? Yeah, but what action does it self carry out? It donates a pair of electrons. By definition, a nucleophile is a Lewis base. It's an electron pair donor. Okay, nucleophiles always donate a pair of electrons. Okay, so a species that donates a pair of electrons. You can even simply say electron pair donor. Okay, that's fine. Identify the nucleophile. Cyanide ion, right? Sorry, इसका minus charge भी एक second. And make sure you draw the lone pair, okay? Better to, because you want to show that it's going to donate a pair of electrons. Explain why the reaction is described as a substitution reaction. Bro, no, why is it described as, see, this is, no, it's not asking why do halogenoalkanes undergo substitution. They're saying, why is this, अगर आप सिर्फ reaction को देखो, तो इसको substitution reaction क्यों बोलते हैं? Exactly, that's all you have to say. Br is substituted by CN. तो वही कह रहा हूँ ना, बंदा होशियार जाते हैं वो बोलते हैं देखो. So Br is substituted by CN. State the reagents and conditions needed for 1-bromobutane to form this amine. Amine के लिए क्या conditions चाहिए होती हैं? याद है देखो. Halogenoalkane to amine. Very one of the rarest reactions to show up. बहुत कम आते हैं ये exam, लेकिन आ जाता है कभी कभार. It was, you need ammonia, that's the reagent you need, right? And if you guys remember, it was either in a sealed tube and heat, or ammonia and ethanol and heat under reflux, right? So you can just say heat in a sealed tube. Heat in a sealed tube. Here the ammonia acts as the nucleophile and it replaces the bromine. All right. Equal amounts of 3 different halogenoalkanes are added to 3 separate test tubes. An equal amount of aqueous silver nitrate and ethanol is added to each test tube. The time taken for a precipitate to form is recorded for each halogenoalkane. Iodide took the shortest amount of time and the chloride took the longest amount. Explain this trend in reactivity. So why did iodide react the fastest and why did chloride react the slowest? क्या कह रहे हैं? क्या? Yeah. Valence electrons are further away. Basically, the bond strength, no? It's a larger atom, so longer bond. So that means it's a weaker bond, lower bond energy, right? So वो ज़्यादा आसानी से टूट जाता है. It requires lesser activation energy, which means it has a faster rate, right? So we can say that over here we can say that क्या था? Describe and explain this trend. So we can say that it becomes increasingly reactive from Cl to iodine, right? Or down the group. We can just say Cl to Br to iodine. Because down the group, the C halogen bond strength, or you can say CX bond strength, decreases. Okay. Which means that lesser energy is needed. Lesser energy needed to break the bond. Okay. All 3 halogenoalkanes tend to react via the SN1 mechanism. Why do they prefer the SN1 mechanism? They're all tertiary halogenoalkanes. So they all form tertiary carbocations. You see this? The carbon atom is bonded to 3 methyl groups. So that's the most stable type of carbocation. Yeah. Primaries prefer SN2 because there's enough space for the guy to attack simultaneously as the bond is breaking. And primary is unstable carbocation. This is less unstable, so more stable, we say that, right? So we say that they're all tertiary halogenoalkanes. All 3 are tertiary halogenoalkanes, right? Hence, they form a relatively stable, and it's relatively stable, it's not actually stable, a relatively or a more stable tertiary carbocation. Intermediate. Okay, and why is this tertiary carbocation intermediate stable or more stable? This is due to the electron donating effect of the alkyl groups, or you can say the positive inductive effect of the alkyl groups. Okay. Electron donating effect of the alkyl groups. This is also known as a positive inductive effect. I'll write that down. Identify a halogenoalkane which tends to react with an aqueous solution of silver nitrate and ethanol via the SN2 mechanism. Identify a halogenoalkane. Any halogenoalkane, but what type does it have to be? It has to be a primary halogenoalkane. And you have to identify, which means name दे दो, structure दे दो, जो करना है करो, सही है ना? यहाँ पर बस ये हम लोग 4 कार्बन ही ले लेते हैं. 4 कार्बन में if you just took one chlorobutane, fluoroethane, fluoropropane, one chloropropane, sorry, any of them will work, any primary halogenoalkane. One chlorobutane has 3 alkenes X, Y, and Z have the same molecular formula. Describe what is seen when aqueous bromine is added to X, or any of these 3 for that matter. Aqueous bromine with an alkene, what happens? Decolorizes. So what is seen? The solution goes from orange to or brown to colorless. It's sort of a light orangish brown. It's a sort of like a dirty orange kind of a color. X, Y, and Z are reacted separately with hot concentrated acidified manganate until no further reaction occurs. The carbon containing products are shown in the table. Okay, so the first guy. Now, if you guys remember, strong oxidation, what we're doing is we're rupturing the double bond, right? अब पहले वाले में क्या produce हो रहा है? CO2 produce हो रहा है. So that means one of them is bonded to what? 2 hydrogens. So we have a CH2, right? And what about this guy? A ketone बन रहा है. So the C double bond O is where the double bond was, right? The CO is where this bond was. And it's bonded to 2 methyl groups. So that means it's bonded to 2 methyl groups. CH3. So the structure of X is we have CH2 double bonded to C with 2 CH3s. This is what forms the 3 carbon ketone and carbon dioxide. Second one, again, same thing. We have a CH2. We have a CH2 again because we have carbon dioxide. And we have a 3 carbon acid. We have a 3 carbon acid, which means we have a carbon with a hydrogen and this 2 carbon alkyl group, right? Ethyl group. So we have CH2, CH3. Obviously, it's a total number of carbon atoms is 4. 3 here and 1 carbon dioxide. So ये 3 carbon acid बनेगी और ये carbon dioxide. अब आखिरी वाले में आपके पास सिर्फ एक ही प्रोडक्ट आ रहा है. एक ही प्रोडक्ट आ रहा है. They have the same molecular formula, so they all have 4 carbons. तो अगर एक ही प्रोडक्ट आ रहा है तो क्या होगा? दोनों तरफ आइडेंटिकल है ना. इट्स अ सिमेट्रिक एल्कीन. बोथ दोनों तरफ क्या होगा? दोनों तरफ you have a single hydrogen atom and दोनों तरफ you have a alkyl group CH3 and CH3, right? So ये भी 2 carbon acid बनाएगा CH3CO2H और ये भी 2 carbon acid बनाएगा. Deduce the molecular formula of X, Y, and Z. They're all 4 carbon alkenes, so the molecular formula is just C4H8. Right? The structures of V and W are shown. Name the class of compounds that V and W each belong to. What class of compounds does V belong to? Primary alcohols. Yes. दोनों ही अल्कोहल हैं, तो जाहिर है फिर अलग अलग क्यों पूछ रहे हैं. इसी वजह से पूछ रहे होंगे ना. Primary alcohol, and W is a tertiary alcohol. V and W both react with sodium metal. Write an equation for the reaction of V with sodium metal. So we have CH3, CH2, CH2, CH2OH, right? That's V reacts with sodium metal to form CH3, CH2, 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 O minus Na plus hydrogen gas. Sodium metal, if you guys remember, is just a test for the OH group. And yeah. So you see bubbles of a colorless gas is the observation. Name a reagent used to distinguish V from W. How do I distinguish a primary alcohol from a tertiary alcohol? What kind of a reaction will a tertiary alcohol not undergo? Oxidation. So if I use any oxidizing agent, I can use KMnO4, primary alcohol will go purple to colorless, right? Tertiary, no change. If I use dichromate, orange to green for primary, no change for tertiary. So any reagent, you can use any one of these two reagents. So we can just say, let's use acidified dichromate, Cr squared, Cr2O72 minus. Okay, observations with V, that's the primary alcohol. We go from orange to green, right? And with the tertiary alcohol, no change, or you can say remains orange.